Hello students, in this video I will discuss geometrical isomerism in Spiro compounds. Okay, so I am doing this video on requirement of one of my subscriber. So here generally to exhibit the geometrical isomerism that must be planar. Okay, this compound actually planar compound. So in this planar compound, if two similar groups on the same side, that is a cis isomer, or opposite side, that is a trans isomer. You can see this one here, it is a planar compound. So in this planar compound here, similar groups on the opposite side, so it is a trans isomer. Okay, so here in this case the condition is must be planar compound. So now here you can see here this is cyclobutane, that is a dichloro derivative of the cyclobutane. Here cyclobutane also here exhibit the that means cyclic rings also exhibit the geometrical isomerism. When here at least two carbons having the different groups. Here all carbons in the same plane. Okay, all carbons in the same plane. Now here for suppose you can see here in this case all carbons in the same plane. For suppose you can see this here, this one, just wait. Yeah, here in this case see this. So here in this case it is a cyclobutane actually. Okay, in the cyclobutane here actually here in this case this is above the plane, this is above the plane, this is below the plane, this is below the plane. Okay, here above the plane chlorine, here below the plane chlorine, so it is a trans isomer actually, because here in this case all carbon atoms in the same plane. That's why here we can say geometrical isomer. Here similar groups are one above the plane, one below the plane. Okay, or maybe similar groups on the same side, or maybe similar groups on the same side, that is a cis isomer. That means here both similar groups above the plane. Okay, here both similar groups above the plane, this is above the plane, this is above the plane, so it is a cis isomer. So here in this case that carbon atoms are in the same plane, that's why we can say cis and trans isomers. Okay, so here in this case so in case of the Spiro compounds, it is actually Spiro compound. Okay, it is a Spiro compound. So in this Spiro compound the compound is not planar compound because this carbon is a sp3 carbon. Okay, this sp3 carbon. Okay, so here because of the sp3 carbon, these two rings are perpendicular each other. Okay, those two rings are perpendicular each other. For suppose here these are the two rings. Okay, these two are the perpendicular each other. Now here yeah, here in this case two rings are perpendicular each other. So here in this case this one group above the plane, one group below the plane. Here these two are on the same plane, so we cannot say similar groups on the same side or opposite side. So this system is not suitable to exhibit the geometrical isomerism. Okay, because these atoms are perpendicular each other, these are not on the same plane. Okay, now here so here one more cyclic ring is attached to the other cyclic ring. So here in this case we can see that geometrical isomerism. Okay, so just you can see here. Yeah, here we can see when when three rings are connected each other. So here first and last ring are in the same plane. Okay, na? You can see here in this case these two rings are in the same plane. This is the first ring, here second ring, and this is the third ring. These rings are in the same plane. Now here in this case you can see here these atoms and these atoms are in the same plane. Okay, these atoms and these atoms are in the same plane. So here in this case, this is the green ball, here this is the green ball, here both are above the plane. Okay, you can see here in this case both are above the plane. Here in this case, this is the white ball, this is the white ball, these two are in the below the plane. So you can see here geometrical isomerism for this compound. Okay, so it is a cis isomer because here this ring and this ring are on the same plane. So here two similar groups on this below the plane or above the plane, it is a cis isomer. Okay, so here this compound we can write like this also. Okay, here in this case in a 2D representation we can write like this here. So here hydrogen has the same side, it is a cis isomer, your opposite side this is the trans isomer. Okay, that's it. First suppose here this is a one compound, your double bond is directly attached to the cyclic ring, here hydrogen, here see here in this case below the plane hydrogen, here above the plane chlorine. So actually here this cyclic ring carbon atoms and this C double bond C are in the same plane, and here this hydrogen also in the same plane, but here one below the plane, one above the plane. This is also not suitable to exhibit the geometrical isomerism because all these hydrogen chlorine atoms are not in the same plane. For suppose if two rings are attached like this, there is a double bond, here this one. Okay, here in this case here hydrogen below the plane, this chlorine above the plane, here maybe hydrogen below the plane or chlorine below the plane. This system again is suitable to exhibit the geometrical isomerism. We can say here this is a cis isomer. Okay, for suppose here this system is not suitable to exhibit the geometrical isomerism, but here again this system is suitable to exhibit the geometrical isomerism. Okay, hydrogen and this is a chlorine. So totally this is a planar system. So here hydrogen same side, cis isomer, opposite side, so we can say trans isomer. Okay, so here when two cyclic rings are connected, those two rings are perpendicular each other, so this system is not suitable to exhibit the geometrical isomerism. But here whenever three rings are connected each other, so here in this case this first ring and third ring are in the same plane, so here we can say that means here that similar groups may be yeah, same plane, that means here may be above the plane or opposite planes, so we can say cis and trans isomer. Okay, thank you for watching.